In this particular problem, we are going to perform thermal analysis of a fin tube structure. This particular fin tube is prepared out of aluminum alloy, and here, due to symmetric nature present inside the geometry, we have modeled quarter geometry only. Then this particular tube carries hot fluid in interior region and there is a convection condition at the exterior region. So we need to apply uniformly varying temperature load on the inner surface, and then we need to find out the temperature distribution throughout the fins using convection mode of heat transfer inside Ansys workbench. In order to perform analysis on this aluminum fin tube, we have Ansys workbench, and select this steady state thermal and place it on the project schematic. Now double click on the engineering data, go to engineering data sources, then go to general materials library and the general materials library and select this particular aluminum alloy and add it to the my present analysis. Now close the engineering data, then right click on the geometry cell, import geometry and select this particular fin tube and double click on the model cell. There is a special requirement that we should not be applying a uniform temperature, but we have to apply a uniformly varying temperature on the interior face of this particular fin tube. So for that, go to the geometry and change it from the structure steel to the aluminum alloy. Mesh, then right click and generate the mesh. Then apply the boundary condition, that is the temperature, and that to uniformly varying temperature as specified in the problem. Now at the starting the temperature is around 200 degrees and at exit the temperature is around 150 degrees and it is uniformly varying along this particular path. Right click, insert, select temperature and select this particular interior face and apply it. And now here if I enter the value, it will be constant value across this particular face. But what do we want this? The uniformly varying temperature which starts at 200 here and the end at 150 degrees at this particular end. For that, change this from constant to function, and the function value is 200 minus 0.25 into y, and this particular y ranges from 0 to 200. Okay, now if this y is 0, then 200 minus 0.25 into 0, the temperature will become 200. Likewise, if the y is 200, 200 minus 0.25 into 200, it will become 150 degrees. So this is how we can apply uniformly varying temperature if in the case of structural analysis. You can use the same equations to apply uniformly varying loads on different structures. Now we need to give the convection. For that, right click, insert, select convection and select all other outer faces and select apply and change the film coefficient it to tabular here. In the tabular data, it is asking as what is the independent variable of this particular problem. The independent variable is the temperature. So select temperature. See here, a table has been updated here. We need to give the temperature, and based upon the temperature, we have given this particular column to give the convective coefficient. So at 0 degrees the convective coefficient is 0.04, then at 10 degrees it is 0.054, and at 20 degrees this particular convective coefficient is 0.06. At 40 degrees it is 0.0066, and then at 60 degrees it is 0.0007, and finally at 100 degree centigrade it is 0.0077. So this is how our convective film coefficient is going to vary with the temperature. So here we can see the variation of this convective film coefficient with respect to temperature. Before going to solve, we need to define this ambient temperature, and the ambient temperature is around 20 degrees. Right click, solve it, again right click, insert, go to thermal and select the temperature and evaluate all the results, and we will be able to see the temperature distribution inside this aluminum fin tube. If we right click and insert and go to this thermal and go to directional heat flux and select this particular surface or otherwise leave it to all bodies, we want the heat flux for all body. Just right click and evaluate all the results. We can see the heat flux through every surface of this particular aluminum fin tube. So this is how you can solve convection heat transfer mode problems using Ansys Workbench.